Securing workloads and containers in Kubernetes is critical to maintaining the integrity, confidentiality, and availability of your applications. Following provides the details on security considerations for workloads, containers, pod security standards, PSS, and their alternatives. 1. Security considerations for workloads and containers. A. Container image security. Use trusted images. Only use images from trusted sources, such as official repositories or verified vendors. Scan images for vulnerabilities. Use tools like Trivy, Claire, or Anchor to scan images for known vulnerabilities. Minimize image size. Use minimal base images, example, Alpine Linux, to reduce the attack surface. Avoid running as root. Run containers as non-root users whenever possible. B. Resource management. Set resource limits. Define CPU and memory limits to prevent resource exhaustion attacks. Use limit ranges and resource quotas. Enforce resource constraints at the namespace level. C. Network security. Use network policies. Restrict pod-to-pod communication using Kubernetes network policies. Encrypt traffic. Use TLS to encrypt communication between services. Avoid exposing unnecessary ports. Only expose ports that are required for the application to function. D. Secrets management. Use Kubernetes secrets. Store sensitive data, example, passwords, API keys, in secrets instead of config maps. Encrypt secrets at rest. Enable encryption for secrets stored in ect. Use external secret managers. Integrate with tools like HashiCorp Vault or AWS Secrets Manager for advanced secret management. E. Runtime security. Use security contexts. Configure security contexts at the pod or container level to enforce following security settings. Set run as non-root as true. Set allow privilege escalation as false. Set read-only root file system as true. Drop unnecessary capabilities. Set capabilities.drop to all to remove unnecessary Linux capabilities. Use AppArmor or Secomp. Apply AppArmor or Secomp profiles to restrict container behavior. F. Monitoring and auditing. Enable audit logs. Track API server activity to detect unauthorized access or changes. Use monitoring tools. Deploy tools like Prometheus, Falco, or sysdig to monitor runtime behavior and detect anomalies. 2. Pod Security Standards, PSS. Pod Security Standards, PSS, are a set of predefined security profiles that define best practices for securing pods in Kubernetes. They are enforced using the Pod Security Admission, PSA, controller, which replaces the deprecated Pod Security Policies, PSPs. A. PSS Levels. PSS defines 3 levels of security policies. Privileged. No restrictions. Intended for trusted workloads or system-level components. Baseline. Minimal restrictions to prevent known vulnerabilities. Suitable for most workloads. Example, disallow privileged containers, enforce non-root users. Restricted. Highly restrictive, following security best practices. Suitable for security-critical workloads. Example, enforce read-only root file systems, drop all capabilities. B. Pod Security Admission, PSA. PSA is a built-in admission controller in Kubernetes v1.22+ that enforces PSS. It operates in 3 modes. Enforce, rejects pods that violate the policy. Audit, logs policy violations but allows the pod. Warn, displays a warning but allows the pod. Reach out to us for the example PSA configuration, baseline and restrictive PSS policies. 3. Alternatives to pod security standards. While PSS and PSA are the recommended approaches, there are other tools and methods to enforce pod security. A. Open Policy Agent, OPA, Gatekeeper. OPA Gatekeeper is a policy engine that integrates with Kubernetes to enforce custom policies. It provides more flexibility than PSA and supports complex policy definitions. Example use cases. Enforcing pod security standards. Restricting image registries. preventing privileged containers. B. Kyverno. Kyverno is a Kubernetes native policy engine that simplifies policy management. It uses YAML for policy definitions and supports mutation, validation, and generation. Example use cases: enforcing pod security contexts, automating namespace creation, restricting resource usage. C. Custom admission controllers. You can create custom admission controllers to enforce specific security policies. Tools like Kubernetes or KRail can be used for this purpose. D. Third-party tools. Aqua Security provides runtime security and compliance for containers. Sysdig Secure offers runtime security and forensics for containers. NuVector delivers container security with network and process monitoring. 4. Best practices for securing workloads. Regularly update Kubernetes. Keep your cluster and container runtimes up to date. Use namespaces for isolation. Separate workloads using namespaces. Implement role-based access control. Restrict access to Kubernetes resources using role-based access control. Monitor and audit. Continuously monitor and audit cluster activity for suspicious behavior. By combining pod security standards with tools like OPA Gatekeeper, Kyverno, or third-party solutions, you can effectively secure your workloads and containers in Kubernetes.